Welcome to my presentation. In this presentation, we shall look at some more examples related to scientific notation. In this example, I want to explain a, a physics-related problem, and then here we are going to use scientific notation because the distance from one planet to another planet is a very large number, and we can use an example from physics to be able to explain these scientific notations. Let me draw a small figure here, and I want to say if this here is Earth and if this here is the planet Mars, and if the distance between Earth and Mars is, let me write this, distance between Earth, from Earth to Mars is 140 million miles, 140 million miles, if that is the distance. And let us say there is a space shuttle which is, I'll put that as a vector here, and if there is a space shuttle which is trying to start from Earth and then travel towards Mars, and if the speed of the space shuttle, I'm going to say speed of this space shuttle is equal to approximately 400,000 miles per day, that is a very, very fast speed, 400 miles a day. We want to know how many days does the space shuttle which starts from Earth take to reach Mars. So that is the question. So to explain this, we're going to break it down into these different steps, and then we'll find that out. From physics, we know that the definition of speed is equal to distance divided by time. And then in this case, if we call speed as s and distance as d and time as t, we can also express the same formula as s equals to d divided by t. Since we want to find the time which the space shuttle is going to take to reach the Mars, we can rewrite this formula in terms of time. So the way we can write it in terms of time is as follows: time t is equal to the distance d divided by the speed s. So the distance from Earth to Mars is 140 million miles. That is the distance from Earth to Mars, and the speed with which the space shuttle is traveling is 400 miles per day. 400 miles per day. We can express these quantities, these very large numbers, in terms of scientific notation, and then let us write that down in terms of step number 2. So time is equal to, we can express distance in terms of scientific notation as follows. I'm going to write it right here. The decimal place is right there. We're going to move the decimal place to the left so many places, 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So therefore we can write that as 1.4 times 10 to the power of 8 miles. That is the distance between Mars and Earth. And then we can express the speed with which the space shuttle is traveling in terms of scientific notation as follows. The decimal place is there, and then we're going to move it 1, 2, 3, 4, 5 places to the left. So we can write that as 4.0 times 10 to the power of 5 miles per day, right? And when we look at the units, the miles in the numerator, the miles in the denominator cancels out, and then in step number 3, when we simplify it further, the time, we can express this one as 1.4 divided by 4.0 times 10 to the power of 8, which is in the numerator, and then we bring up the value which is in the denominator, 10 to the power of 5, which is in the denominator. When we bring it up to the numerator, we can express that as a negative exponent, and therefore when we simplify it further, this is going to be equal to 1.4 divided by 4.0 is going to give us 0.35 times, because since the bases are the same, we can write the base ones and then we can combine the powers, 8 minus 5. So 0.35 times 10 to the power of 3 is what we are left with. So therefore 10 to the power of 3 is nothing but 0.35 times 1 followed by 3 zeros. When we take 0.35 and multiply by 1000, that's going to be equal to 350. So 350 time is equal to 350, we get the value in days. So it takes 350 days for the space shuttle, which is traveling at a speed of 400,000 miles per day, to reach Mars, which is 140 million miles away from Earth. So this example illustrates that we have very large numbers to work with, and then we were able to express those very large numbers in terms of scientific notation, and we were able to express it, use basic laws of physics, and then be able to figure out the amount of time a space shuttle takes to travel that particular distance. Thank you for being with me for this presentation. We will have some more very, very soon. Thank you.